return before 1 second. For the first bucket here, as you can see, so the queries, they go from 1 year to the entire data. And the good thing is the execution time of this query is like very close. That means, as you can see, the scatter and gather principle is really working well, and the time is bound by only the scan of one partition. So that's really good in there. And the more the filters that becomes sort of selective, the closest is that gap in between the max and the mean time, and so is average. The second bucket of interest is where we have actually one group by key, and the same thing here. You start by querying all the data, and then you have filters that they become more and more selective. There is only one outstanding query there, which is the 2.2, if I'm not wrong, that takes almost 2 seconds. And actually, at the beginning, it took even more than 2 seconds. It wasn't like in the order of like 100 seconds. And we have spent quite a good time about this, and we have figured out that the actual, I shouldn't say the problem, but the actual issue is the fact that this query, it has a bunch of OR clauses, and in Druid, the OR clauses, when you push the filter, it is actually a union of bitmaps. So we had to go from unioning the bitmaps using the concise implementation to the raw implementation. So by going there, we get into the 2 seconds, and we're still doing some other works actually to make Druid avoid the unions if you know that the scan of the segment will be faster than actually doing the unions of the bitmap. But overall, the same thing. You see that the more the filter becomes selective, the faster it is a query. The same thing for the query number 3. We are adding more group by keys, but we are having the same execution time. The same thing for the group by for the class 4. We actually have added, or we add even more group by keys, and stuff still tracking in the same order. So overall, pretty good result for what we have put in there. So now the question that you might ask is like, okay, so this query is almost, or it is executed 100% by Druid. What is the overall impact that adds it to go through Hive? And we have measured that, and we find out that on average, the query will take 300 milliseconds more, and that's due to mostly to compile the query in Hive, send it through the HTTP, and get the result back through the JDBC to the client. So in some of the query, it is sort of like silly, because in 3.3 actually it took more time to compile the query than to get the result from Druid. But it's still like in 300 milliseconds, it is still acceptable. So that's Hive, that's Druid. So the last batch that we have done, which is the most important one, is the concurrency, right? It's like you want to make sure that how your system will be scalable if you add more and more users. The good thing here, we see a very good trend, which is like a linear trend. There is nothing that really spikes very badly when you go from 1 user to 15 users with 10 nodes. Everything still track in a linear way. That means you can scale actually like horizontally. The more you add nodes, the more you will get capability out of your hardware. The last benchmark that we have done is, because you might be saying, well, you are a little bit cheating here. You are denormalizing the data. You are doing all the join up front, and everything is in there. So we decided to compare with Hive when the data is actually not, when the data is in the normal form. That means you will have to do all the join and stuff like that. And also when the data is denormalized, when all the joins is done up front. So what you see in the green bars here is when the data is actually in the normal form, where you will have to do the join and everything. And the yellow data in there is when the data is actually denormalized in Hive. What I'm plotting here, this is the speed up of the query, Hive over at Druid. And as you can see here, for the first set of query where the actual join is in between two small tables. So the good thing is actually Hive is almost performing as good as if the data is denormalized or not denormalized. And that's because Hive is able now to push a lot of the filters down.
So when you say normal form, is it that is being stored in HDFS?
It is stored in a HDFS in an org, and you will have to do the joins to answer to the query. In the HDFS, and the data is denormalized, so you don't have to do any join, right?
This is not involving Druid. This benchmark.
This benchmark is involving a Druid because I'm plotting the speed up, right? So I'm.
Okay. So this numbers compared to.
So this is the speed up of. So this is the execution time taken by Hive, divided by what you will do by Druid. And the first one, the green one, is Hive normal form, where you have to do the join and all the work. And the other one is when you don't have to do any of the joins. What is interesting here is for the first, let's say, set of 7 queries there, the performance of Hive is the same if you have to do the join or not. And that's because actually Hive is now doing a very good job at pushing the filters down. So the actual join, they are very minimal comparing to the time that you have to spend actually to read the data from HDFS and answer to the query. And in that range here, we still have 1 order of magnitude of speed up comparing to Hive when the data is in the normal form or is not in the normal form. So you are getting a huge speed up by putting the data in Druid, even if you are trying to put it in a denormalized form in Hive. When we go to the other side, where the actual join becomes between the 3 tables, the result is even more, the gap is even more big between Druid and Hive in the normal form, where we can achieve like an improvement of 100 times faster because of the joins. So I guess with that, I'm done here. The conclusion of what we have done. So this work is a very beneficial work for both communities, Hive and Druid. From the Hive side, we'll be able to get to actually be able to answer to query in real-time, interactive way for queries. From the Druid side, we'll be able to query the data using SQL, drop, load the data, and doing some stuff like joins, windowing, and stuff like that. The future work, it is the materialized view. It is a big umbrella there. What I haven't said in this talk is, so those queries that they come from the SSB benchmark, I will have to go and rewrite them myself to go from the normal form to the denormalized form, right? So with the work that we are doing now, eventually the DBA will be creating the denormalized form, but Hive will be smart enough to actually rewrite the query that has the joins in itself to that index itself. So the user won't have to rewrite the query by himself. You will be writing a query that has a bunch of joins, and Hive, under the hood, will understand that, oh, the join has been already materialized in Druid here, and now I can rewrite this query to a single query that goes to Druid and gives you the result back. So that's definitely very cool. And keep tuned. So with that, I will be done here. This is a short demo of done by Carter, where he's hooking up actually Tableau to Hive to query Druid using this SSB data set. If you are more interested in this, you can check our blogs. There is the one that talks about the integration. There is the one that talks about the benchmark. With how to reproduce that, and the last one is to talk about how to connect Tableau to Druid via Hive. That's it. 22 minutes, not bad.
I got a question.
Sure.
So when you ran the Hive benchmark, was it with LLMP cache on or off?
Off. Yeah. Want to make sure that there is no caching. Actually, the caching will only come when you query the same data again, right? So.
Yeah, so the second Hive query with caching compared to Druid might be something.
Yeah, but that won't be really very fair. No, I'm not using the cache in Druid as well. So,
But you have bitmaps, right? So the join mechanism might still be efficient. So it would be good to look at where the benefit comes from.
What you mean is it'll catch up.
well, yeah.
No, the bitmap I think will give benefit. I just want to measure whether it's cache giving benefit or bitmap giving benefit. So just curious.
Well, the bitmap is actually different from the caching itself. The bitmap will help you to prune down the records. So even let's say in Hive, if the data in cache, it won't be able to perform as fast as the bitmap because it doesn't have the bitmap, right?
So that would be a good data to collect, right?
Sure, yeah. Next time we'll have it. Sure. Thanks. All right.
Cool. Thanks.
Thanks.